start the next session, the discussion about the green hydrogen. So the first speaker is the Chief Technical Officer of SPIC Hydrogen Energy Technology, Mr. Maorong. He is going to talk about the platinum technology innovation that leads to the development of green hydrogen. Today, my topic is how the platinum technology can lead the development of hydrogen economy. So there will be three parts to my presentation. First of all, the position of the hydrogen power in the future energy structure. And then second, I'm going to talk about the current development of hydrogen technology. Then how platinum technology can lead the development of hydrogen technology and our investment practice at SPIC. So why should we develop hydrogen power? Well, in the 2020s, in the 75th anniversary of the UN, President Xi made it clear that China will strive to achieve a carbon peak by 2030 and achieve carbon neutrality by 2060. Now, we can see the carbon peak target is not a big problem at the moment, but the carbon zero is a big issue, is a big problem at the moment. As you know, our energy rely heavily on coal. And last year, the coal takes 56% of the total energy consumption in China. Actually, years before, it takes up to over 60%. Compared with the natural gas, which is widely used in Western world, the carbon emission by burning coal is 2 times that of burning gas. If we are switching to natural gas, or if we are producing a hydrogen using the natural gas, then it will also contribute extra to the carbon dioxide. So using hydrogen energy is not only about generate hydrogen using the fuel cells, using fossil fuels, but it's about using more renewable energies to totally cancel out the carbon dioxide. So the fossil fuel consumption is very high in China, and so that leads to the high carbon emission every year. So if the carbon emission grow at 3% yearly, then by the 2050, then it's going to reach 13 billion metric tons of the carbon dioxide. Then if we look at the carbon dioxide absorption, it will only 20 metric tons of the carbon dioxide will be absorbed. Well, people say we can use CCUS to sequester the carbon, but that means we are going to bury over 10 billion metric ton of carbon dioxide. I don't think it is even possible. So we need to reduce the CO2 emission. That is the key. Well, we can see from the energy structure that we have a very abundant solar power. If we take only 2.5% of the total energy, it's 2 times that of energy consumption yearly. And the wind power plus the hydraulic power can support the energy consumption of 0.6 years and 0.1 years respectively. So in other words, the renewable energy can totally meet the demand in China. But the simple thing is the renewable energy, it's intermittent. The wind, for example, only generate when there is wind, or the solar power only generates when it's in the daytime. While facing the large energy demand, relying simply on renewable energy or the hydraulic energy is simply like putting out a fire using small bottles of water. So we need to make sure that the hydrogen need to come from the renewable sources instead of the power grid. In the past, we only use fossil fuels to generate hydrogen, but now we have to switch course. So electrolysis is more about absorbing the intermittency or excessive renewable energy. So we need to get clear on this. In the future, there will be two networks in the power grid. One is electricity. Electricity will take a central role in our energy consumption, but the biggest thing is the power grid is not stable. We believe that in the future there will be two networks, one electricity, another hydrogen. We need renewable energy, then the energy can be consumed through the hydrogen network. So when for example, during the night, when there is no solar power, then the power stored at the hydrogen source or storage can be used. So in other words, these two networks can complement each other. So that's why we believe that developing hydrogen economy is a necessity for us to ensure the energy security in the future. Then let's talk about the technology. The hydrogen power technology is not possible without precious metal. But first of all, we need to get clear on what is a green hydrogen. Well, electrolysis is not necessarily green hydrogen. According to the IAE, there is a very clear definition of green hydrogen, namely every kilograms of the hydrogen should produce less than 4 kilograms of CO2. So when it gets this standard, it can be called a green hydrogen. So it's just like we see NEV as a totally exhaustion-free solution, but and actually producing the battery is also polluting the environment and then taking a lot of energy. So we need to look at this whole life cycle. Well, just as I said, and the electrolysis is just one way to produce hydrogen. So there is a few pathways, and PEM is one promising pathway. As I mentioned, the hydrogen is most of all a way to absorb the excessive and renewable energy like solar and wind. And hydrogen storage can be stopped and started anytime you need. So PEM, this pathway is highly demanding technology-wise. It requires a highly purified water, but in the future, with the breakthrough in the technology, you can also be taken from this ocean water. For example, in some universities, they are already looking at these possibilities. The biggest disadvantage of hydrogen storage or hydrogen power is it needs to use precious metal like platinum and iridium. Today we are discussing the application of PGM. So platinum and iridium are very important elements in PEM. Platinum production yearly is at 220 metric tons. So 220 metric tons are taken from the mines, and 60 metric tons are recycled. While iridium is even less, only 3 to 5 metric tons of iridium were produced every year. So if we are going to adopt a PEM pathway, the most important thing is how to reduce the use of precious metal. I think I'm going the opposite way towards the spirit of today's meeting, but we have to also admit that we only have scarce resources and a scarce amount of precious metal on the earth. So the future trend will definitely be reducing cost, improving the scale, and so it is inevitable that we are trying to reduce the use of precious metal because precious metal is a scarce resource. So we need to find solutions find a better solution. So namely, we can switch in between different electrolysis pathways like the AWE, PEM, and SOEC. So all these three pathways can be mixed together, considering the raw material level. And also the hydrogen use is correspondent to the production of renewable energy. And so far, the hydrogen only takes 0.1% of the total energy used, but in the future, it is going to be increased to 12%. Well, 10,000 metric ton of hydrogen can only produce 500 million kilowatt hour of electricity. If we are to replace electricity, if we are to replace fossil fuel, we use renewable energy, but the electricity should never be replaced, and the electricity should never be produced using fossil fuels, since we are already moving away from fossil fuels. And also, the producing electricity from fossil fuels only have a conversion rate of 40%, which is very, very low. So a PEM mechanism is very simple. But on the anode, it needs platinum, and on the cathode, it needs iridium. So we have to use iridium because its potential is very high. 1.68 voltage is the base level or base potential. So when people talk about 3 kilowatt hour or 4 kilowatt hour, it depends whether it is 1.8 voltage or 2.8 voltage. So the lower the voltage, then the efficiency is higher, but the current density is lower. In each centimeter and square centimeter, and we can totally make it a higher voltage, lower voltage, but the current density is very low, so the efficiency will be reduced as well. So on one hand, we want to reduce the voltage, but on the other hand, we also need to improve the electric current density.
So if you take a look at the history of PEM, for catalyst, we need highly efficient catalyst. We use a highly corrosive catalyst, carbon with the coating of platinum on the surface. Here, platinum plays a role, but I'm not sure if we can find a better one. So in terms of the membrane electrode, of course, platinum plays a role here. So here, the synergy between upstream, midstream, and downstream technologies is needed. Lastly, we want to achieve integration of wind, solar, and hydrogen power in order to achieve maximum efficiency. And the third part is about platinum technology innovation leads technological development, and SPIC independent practices, because SPIC, we have two focuses. One is technology focus, and the second, we focus on product system. For technology, we have membrane electrode as well as bipolar plate, carbon paper catalyst, and PEM. We develop ourselves in-house, and we use it in our products. As for the product system, we have the fuel cell product lines as well as PEM producing hydrogen product line. And the goal is we want to develop products ourselves. We want to have high performance products at low cost. That's basically our strategy. And in terms of the R&D of core technologies, and the platinum is very near and dear to our technology, but platinum is used in PEM as well. For example, small amounts of palladium ions are used in the PEM to reduce the activity oxygen. However, domestic speaking, a lot of PEM manufacturers from China remove or get rid of palladium. The platinum and the palladium are near and dear to our technologies. As for the rest of the group of PGM, I don't think they are relevant, so I will skip introduction of them. And I will focus on catalyst, as catalyst is key to fuel cell. So our main focus is we try to use nano distribution or dispersion technology in order to reduce the amount of catalyst, platinum-based catalyst used. That's basically our focus. Another thing is using nano the catalyst may not necessarily be of high activity, so we considering complex in order to make it 110 surface exposed. In other words, the hexagonal surface we expose, because the platinum has two surfaces. One is four-sided, which does not have activity, whereas the eight-side surface has activity. So we try to use complex to make the surface exposed to improve its activity. A lot of people think about using PVD or CVD as catalyst, but they have never succeeded because platinum-wise, it has its flaws. The surface, the activity surface must be facing upward. If the surface faces downward, then it's useless. For four-sided surface, it's of no activity at all, so it's of no use. So one of our key work is to improve the activity. Why do we need to use the platinum, as you can see from the slide? Because the reduction and oxidation potential site is at the maximum level. For example, for ruthenium oxidation activity is rather low, so it's not as active as the platinum. As for rhodium and palladium, they are too active for reduction, and the activity for oxidation is too low. So from this chart, you know that platinum is at the very top of the volcanic chart. In other words, its oxidation and its reduction activity are at the top. In addition to catalyst, when you produce a vehicles, you must make sure that the vehicles have a long life, which means that the catalyst must have durability. That contains two parts. In terms of part one, when you talk about the smelting, you need to have a more stable carrier to stabilize it. Another thing is anti-toxicity. We use platinum to increase its anti-toxicity property. We improve the stability of the carrier to improve the durability of the catalyst. And personally, I have been devoted my entire life to catalyst. I started my work as early as 1980s, and I have spent more than 40 years in this field. So my understanding of this, I would say that I have deeper understanding than those who have never have any practices in this field before, because platinum, one of the earliest versions of platinum-based catalyst was also developed by me. I have spent my entire life focusing on this very specific field. So I want to work with you to make the best use of platinum, as the platinum has a long life and it's recyclable. Another part of catalyst is about the processes of producing catalyst. A lot of people say that the catalyst is good, but how can you manufacture it? And when you do MMA, it's 385 as opposed to 200 that I do myself. The difference lies in the key technological processes of catalyst. So speaking of a platinum compared with TKK, we have higher activity than TKK's catalyst. For platinum carbon, we can achieve 380 plus. If we want to do anode catalyst, actually we can make the number more than 800. In other words, 1 gram of platinum, how much electricity you can generate. It's a indicator measuring the activity of catalyst. Another part about catalyst in the industry in China, the biggest problem is that we don't achieve scale production, because for catalyst, when it comes to catalyst used in fuel cell, only dozens of grams are used. That means that you have to be of great homogeneity cross batches. For example, in one stack you have 150. For the next stack you cannot tolerate 120. So you have to have a high batch consistency as well as homogeneity. Again, as I've spent my entire life working on catalyst, I have several key control points that I think of great importance. I want to bring your attention here. In addition to catalyst, we have developed various types of fuel cells technologies and products, including 80 kilowatt hours that are used in buses. And the first generation is 80 kilowatt hour, and then I developed 110 that's compatible with passenger vehicles, as well as 150 stack that's used in heavy duty vehicles, each with their corresponding systems. We have also developed some liquid or air cooling stack. In addition to that, in terms of applications to robots, to boats as well as autonomous driving, you You may have read recently a report that last month to Wuhan City, we helped them with 200 fuel cell buses to be delivered to Wuhan City. We already delivered 200, and we are about to deliver 200 more. And we also have good sales in other parts of China. At the end of June, we expect sales of 600 fuel cell buses. This is what we have achieved during Winter Olympics, direct vis-a-vis Toyota. Our bus, the bus we produce is responsible for the most difficult section from the bottom of the mountain to the top of the mountain, and 6 commuting times. And in total, our fleet ran 900,000 kilometers, carrying 160,000 passenger trips. And we got reports by authoritative media outlets from China, including the Central Television Station as well as People Daily. I featured personally on these media reports as well. So the fleet that we supplied to the Winter Olympics, starting from June 2021 until now, has been running for 2 years. They have been in operational status throughout the past 2 years. In other words, instead of liking other fleets, the fleets that are abandoned right after an Olympic game or any major conferences because they already get the subsidy, the fleet are removed. We are a state-owned company. We have to make sure that these fleets can keep running. So one of the buses or a few of the buses run the longest distance of 160,000 kilometers. So these are some of our hydrogen demonstration projects, including the ones that run on Badalin Great Wall, as well as our alkaline electrolyzer and 50 sets of PEM electrolyzer with total, that company wind and solar integration project with 65 megawatts. And in Inner Mongolia as well as in Xinjiang, we have conducted several projects of using PV to generate power as well as electricity. In other parts, in Hubei province, we have the hydrogen internal combustion engine, and in Zhongguancun in Beijing, we have a hydrogen refueling station. In Shanghai, we also have a hydrogen refueling station, and this is something that was done by our subsidiary Xunhua. We plan to do more, including production of hydrogen using nuclear power. In a word, SPIC is one of the largest state-owned energy companies in China. We live by practices. We contribute to China's dual carbon initiatives with our Acts and Ds. Thank you very much for your attention.